Hey guys, Coach Starch here. Just gonna go over some stuff for your test. I'm gonna post Mr. Fode's review video for you, but I'm also gonna post this video, which is gonna go over Chapter 1, Key Issue 3, the worksheet that I had you guys do, and then I graded and I gave back, but we never had a chance to go over it. Really important that you review some of the concepts in that section. I'm gonna go over some of the ones that were a little bit more challenging, it looked like, from the worksheet. I'm just going to remind you, as a precaution, please do not copy from the book. I know that in the past, other teachers have been cool if you copy definitions word for word out of the book and they told you that you did a great job and that everything was good with your assignment. But when you copy someone else's words, there's no information, or there's no way for you to tell me that you understand the information. All you're doing is taking someone else's words and ideas and putting them on paper. I need to know whether you understand the information. So it's going to be my goal, anytime I give you an assignment like that, to check and make sure that you understand it so that when we assess it, we're good. And for those of you who did try to paraphrase and made mistakes, that's the whole point. When you are reading something and learning some new concepts that are pretty tough, you're gonna make mistakes understanding them, and that's where I come in and I can help re-clarify so that you do well on your test. So I'm gonna bounce around a little bit on the sheet, but the first one I want to start with is number 3. It's a question, reading comprehension question. Does Rubenstein feel we're headed towards one global culture? I think we talked a little bit about this in class, but obviously the answer is no. There's no way that everyone in the world is going to have the same cultural traits, the same language, the same religion. It's just not possible. And Rubenstein doesn't think that it is. He does state that there are certain traits or characteristics that are becoming more common around the world, but that does not mean that we're headed toward one global culture. And he uses the example of Al-Qaeda, which, by the way, is a terrorist organization. It's not some dude named Al who has a problem with the United States. So please, when you write, don't say he did this or he did that. It's a group of people, loosely affiliated at times. So please don't use he. You'll save yourself a little bit of embarrassment on writing. But Al-Qaeda targeted the World Trade Center as a way to show that they're against Western culture and they don't like the ideas from Western culture spreading around the world and threatening some of their local traits that they practice. So understand that that was an example to disprove the idea that we're headed toward one global culture. Please make sure you read the entire section before you decide to write something. It's a good habit to get into. Just read the whole thing. It helps with your reading comprehension, and then you can start writing. Number 4 deals with density. And most of you should be familiar with the idea of density. It's a fraction. It's a ratio. And there's stuff that goes in the numerator, and it's an amount of space that goes in the denominator. And when I'm defining these terms, I'm a math person by nature. I like math. When I define these terms, I like to put them in fractions because, I mean, let's be honest, you are creating a fraction. And so when I define them, they look like this. You see arithmetic density, physiological density, and agricultural density. And it's really important that you understand what these 3 terms are and that you understand what they measure. Now, the first one we're going to talk about is arithmetic density, which is, it can be the number of anything. It can be the number of cars, the number of dogs, the number of chickens, the number of anything that you want to study. But most often we're looking at the number of people divided by the amount of land, total land area. And it gives you an answer, people per square kilometer, people per square mile. This is the most common one that you'll see, and the only reason for that is because it's the easiest to calculate. You take the census, which tells you the total amount of people, and you take photos from remote sensing satellites, and they can tell you the amount of land, divide them up, it gives you a density. Problem with that is it doesn't tell you much about the land, about the society, how stressful it is to provide for the people. So we prefer to use physiological density, which, if you'll notice, has the same exact numerator, but a different denominator. Now it's the amount of arable land. And when we look at the amount of arable land, now we know how stressed the land is to provide food for the people. If you have a really high physiological density, it means that people have to work really hard to provide enough food for all the people who live there. And then agricultural density is the number of farmers divided by the amount of arable land. So you see these two have the same denominator, but a different numerator. Now it's the number of farmers, just farmers, divided by the amount of arable land. This measurement will tell us how efficient the farmers in the country are. The higher the number, the less efficient the society. So if we look at these three things in a little bit more detail, and like I mentioned a second ago, the number of people stays the same in the numerator and the denominator changes. So what we can do when we're looking at these two numbers for a particular country, we can say that physiological density is always going to be higher than arithmetic density, because the number of people is always going to be the same. If we're looking at Bangladesh, for example, they're going to have the same number of people in Bangladesh, but the amount of arable land is always going to be less. When you divide by a smaller number, you end up with a larger ratio. Now, I know there's probably some countries out there where all the land is arable. Not that I know any examples or want to talk about any, but that's why I put the greater than or equal sign. It is possible that they could be equal. When we look at agricultural density, though, number of farmers is always going to be less than the amount of people. Always, always, always. You're going to have people in the government. So when you have the same denominator, but a larger amount of people, this ratio is going to be bigger than this one. And that's always the case. Doesn't matter what country it is. Now, when we compare agricultural density and arithmetic density, we don't know. We have to look at each individual country to make a determination whether the arithmetic density or the agricultural density is higher. In the United States, because a lot of our land is arable and we have very, very few farmers, our agricultural density is much, much less than our arithmetic density. But if you look at a country like Bangladesh, where most of the people are farmers and they have very little arable land, then you're going to have a higher agricultural density, not a very efficient system. It's going to be much higher agricultural density than arithmetic. So when we compare those two numbers, we have to actually do the math. We have to actually do some sort of calculation to determine which one's bigger. But physiological will always be the biggest. Always, always. It's the way it always is in every country. Because you're taking the highest numerator, it could possibly be the total population divided by the smallest amount of arable land, or the smallest amount of land that could be, which is arable land. Please make sure that you understand these three definitions and you also understand what each of them measures, because you're going to be responsible for that on your test. The next question I wanted to talk about is the very next question. It's the one on the maps of the baseball teams. Now, I know it's kind of weird that I asked you guys to analyze maps that are based on baseball, right? I'm the baseball coach, and of course I'm interested in baseball, but why do you care? The maps were used to determine or to kind of show you guys the difference between density and concentration. You know, I just went over three different types of density, the total amount of something divided by the amount of space, but concentration doesn't measure density. It's very different. It measures how those characteristics, whether it be baseball teams or people or farmers, how they are distributed. Are they evenly dispersed throughout the country, or are they clustered together? Right? We can have high density and low density, and we can have clustered and we can have dispersed patterns. And so I can use an example that everyone hopefully can relate to. Instead of teaching you guys through baseball teams, I'm going to show you chocolate chip pancakes. I love chocolate chip pancakes. I had a chocolate chip pancake just yesterday morning for breakfast. It's my favorite. If you don't like chocolate chip pancakes, I don't want to be friends with you because they're my favorite. So we're going to look at two chocolate chip pancakes. Okay, they're even in size, right? But we have one chocolate chip pancake that's very different distribution-wise. You can see in the image, we have one really, really tasty bite of a chocolate chip pancake, right? All the chocolate chips are clustered in one area of the pancake, not evenly distributed throughout the entire area. Over here, the entire pancake is delicious. That's obvious because each bite of chocolate chip pancake has chocolate chips in it, which is what makes each bite taste good. We can have a dispersed pattern or a clustered pattern. If I sat here and counted each pancake, the number of chocolate chips in it, they might have the same density. This one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, about 17 chocolate chips per pancake. That's a density, right? 17 chips per pancake. Here, there's 4, 8, looks like 12. So this one is actually less dense, 12 chocolate chips per pancake, but the distribution pattern of the chocolate chips is clustered. If I went in and added 5 more chocolate chips, now they have the same exact density, 17, 17, but this one has a clustered pattern and this one is dispersed. What the author of the textbook was showing was how the baseball teams became more dispersed over time. Same land area, the United States, but in the old days, all the teams were clustered in the Northeast. And now, as the population of the United States has spread west and south, the teams have become more dispersed, and also they've increased in density because we have more teams. But those two concepts, while they look at distribution, are different. Density is the amount within a space. Concentration is the location of those objects within that space. Are they clustered close together or are they far apart? Now, the last concept I'm going to review with you in this review video is space-time compression. Many of you, again, copied the definition straight out of the book. I understand why you did it, not mad, but we need to make sure we are summarizing, putting in our own words. So space-time compression, the word compress means to squeeze, right? To make smaller. Space-time compression is the observation that geographers have made that the world is getting smaller. Not in actual measurable terms, right? It's the same size the Earth's always been, but in terms of how quickly ideas move from one place to another, in terms of how fast we can ship goods from one place to another, or people can travel from one place to another. So the idea of space-time compression is that the world is getting smaller. Again, not in literal terms, but in relative terms. And what's causing space-time compression are all the improvements in transportation and telecommunications that we've made in the past 100 years, 50 years, whatever. We can now have meetings, me at home, you guys at home, while we're on fall break, and I'm videoing myself, sending you the information over Edmodo, and you can get a lesson to help you prepare for your test in a matter of seconds. I know, I'm being long-winded. We're getting up to 15 minutes almost, which is the cap for YouTube videos, so I'm getting nervous. But the fact that we can do that reflects the idea of space-time compression. The world is so much smaller than it ever has been before. We can go, some of us went on fall break to a different country, visited, hung out with family, saw new sights, whatever the case might be, and came back. 100 years ago, that wasn't a week-long vacation. That was a move, permanent. You went across the ocean and you didn't come back for years, or maybe ever. So the world has gotten significantly smaller because of these advances in communication, and that's the observation that geographers are trying to make. Space-time compression is what is sort of an opposite force in the world of time-distance decay. Remember, we talked about the idea that the further away you are and the longer it takes for two ideas to, or for two people to connect, the less likely it will be for the idea to spread, the less likely it will be to diffuse, the less likely it will be to be adopted. So with space-time compression, it's shrinking the world and making it more likely, more common for ideas to diffuse further distances and for people to communicate over longer distances. I hope this helped. I hope it helped clarify the information in section 3. The other information from chapter 1, key issue 3, you should be able to either figure out on your own or we went over in class. Good luck studying. Can't wait to see you guys on Monday and enjoy the last couple days of break. See you guys on Monday.